Thank you, Daryl, and thanks for the warm welcome. Hopefully we'll get some more people filing in. This talk should be interesting. I'm usually not one to do live demos, but I'm going to do a live demo. I got everything working. It was a little nerve-wracking about 20 minutes ago, but figured it out. So I'm going to actually start off with a little bit of intro content for those of you that don't understand tracing or maybe don't understand what Jaeger does. And then I'm going to dig into how you can build a pretty interesting stack of technologies and leverage a lot of different tooling, including Grafana, Jaeger, and OpenSearch for doing different types of trace analysis. And I'll show you a live demo and a system and kind of explain that. So a little bit on my background is I've been a practitioner for a long time. I spent the first 15 years of my career building and managing infrastructure and security. I was an analyst at Gartner, so I did a lot of speaking and writing and research and advising, and then I worked at several different startups, both in observability and in data. And for fun, I work on OpenSearch. I'm part of the technical steering committee for OpenSearch. I'm a maintainer of Jaeger. That's what this shirt is, our logo. Jaeger is a CNCF graduated project. It's part of the Linux Foundation and a very popular tool for trace analytics. Thanks to the folks at Uber who donated Jaeger to the CNCF. And I also work on OpenTelemetry, which is a big part of Jaeger. And I do a lot of diving, so I put a picture of me finishing a dive. So observability is generally consistent of the three main signals: logs, metrics, and traces. There's other signals starting to come in. People talk about events, people talk about profiling, but generally it's about collecting this type of data and analyzing it for various types of use cases. And the main reason why tracing is really important is because we're all building microservices architectures. We're integrating lots of different components together with APIs. And they're managed by different teams. And when things break, you don't know who to call, who to blame, who made the problem occur. So tracing is designed to help you stop finger pointing and analyze where the problem is and get it fixed so that you can get your customers back up and running. So distributed tracing is specifically designed to help you with root cause analysis and understand the path that a transaction takes within a system. So it lets you really dig into different components within the end-to-end view. These are a few screenshots from Jaeger. I'll actually show you Jaeger, and we'll walk through it. But it really lets you collaborate, look at SLAs and application availability, usage, latency, error rates, things like that. So it's a combination of metrics, which you can see a view in the bottom left of Jaeger showing some of those application metrics that are extracted from traces. Down on the right, you see a view of a trace, and we'll see one live. And then on the right, you see a topology showing you the different services and how they interact with each other. So the first thing that you have to do when you want to trace is instrument your code. And that means being able to collect traces from the application. OpenTelemetry is the way that most people are doing it today. That's what Jaeger uses. And there are various ways to instrument your code. You can manually do it. There's automated ways to extract it. And some folks, even here at the conference, are starting to use LLMs to do instrumentation by putting that code change in for you. The second part of it is once you instrument it, you have to collect it and store it somewhere so that you can ultimately analyze it and visualize it. So those are kind of the steps, is instrument, collect, and analyze. And this is the general design of the Jaeger system. It's a microservices-based architecture where everything is decoupled along these paths, and I'll kind of show you a little bit of that as well. But these are kind of the steps that you have to go through. So I'm going to talk about terminology, so just so that everyone understands. A trace is the end-to-end view of the transaction that's occurring. Inside that transaction, there's a bunch of different steps that we're going to call spans, and those are like each microservice is a span, but the trace is a collection of spans, one or more spans. Inside each span, there's a bunch of metadata. It may tell you about a database that's being called. It could tell you about the web service call that's being made and the URI that's sent along. It could be things that are tagged automatically, like the Kubernetes pod or the node name or various other things that you can attach to a span. The nice thing about traces is that it has a solid data model. So it's like a structured log, basically, and it's way more powerful because the data is always formatted in the right way, whereas everyone knows in logs, free for all. You just kind of do what you want to do with logs. Yes, it would be great to standardize logs, but the nice thing about traces is that we have a clear data model, and so it's much easier to do analytics on it and normalize the data across lots of different technologies. So this kind of is a couple of views of traces. So we have what's called the root span. That's like where the transaction starts. And then it can fan out, and you can have multiple transactions occurring asynchronously and branching off of each other. So these are just kind of ways to visualize the way that traces work. You can either do it showing the path, like on the left, or on the right is over a timeline. So like milliseconds or seconds, time goes on, and then you see how those spans sort of stack up and work. And the spans don't have a lot of metrics associated with them, but generally it's going to be errors, latency, and you can have other indicators, but those are things that come out of the box, so to speak, with a trace and a span. So as we get into the demo, this talk, the Docker containers, all the setup, everything that I'm going to go through is available on my GitHub, and the QR code brings you there if you want it. There's also a link from that repo to the slides and everything else that's attached to it. I wanted to thank YangDB on GitHub, who did a lot of the initial work that I modified. And this is also based on the OpenTelemetry demo that the OpenTelemetry team, there's a bunch of contributors that built that. But it's kind of hard to see this diagram because there's so much going on. But the basic idea behind it is there's a bunch of different components. When you go to that URL, you'll be able to see it. But generally speaking, there is basically the data collection side on the left, which is all the OpenTelemetry collecting the data from the code. And then basically it's flowing into OpenSearch. We're using both OpenTelemetry collector, data prepper is involved. This demo also does metrics and other things I'm not going to really get into. It uses Kafka. So this is kind of part of the back end. And then on the front end, the demo I'm going to show you is a telescope shop, like an e-commerce site. And you'll see that on there's a bunch of different services written in like a dozen languages. They're all microservices that interact with each other. So it's a really good demo that shows Go and .NET and Java and all kinds of stuff, all instrumented and working together to create the demo that I'm going to show you in a minute. And this is kind of the architecture of the application, all the microservices. And the colors, which you can find on this URL, correspond with languages that the things are all written in. And the communication's all gRPC or HTTP here. So there's like a Redis database, and there's Postgres and a bunch of other databases and data stores and Kafka and lots of different components going on. So it's a good environment to play around with. We also have a load generator that's sending traffic through this on my laptop all the time. And that's what we're going to be viewing, is all the transactions flowing through the application that's instrumented. So let me flip over to the little telescope store. We'll take a look at it. So this is the demo. You go shopping. You can add a bunch of these telescopes to your cart, and do your typical kind of e-commerce thing and check out. And there you go, that kind of thing. You can introduce errors and do other fancy stuff. I'm not going to do it for this demo. And then we also have Locust running in this tab, and this kind of shows you all of the requests that are being made. It's constantly processing. It's doing about 3 requests per second on my laptop through this application across various services. You can see them listed. And this is generating all of the data that we're going to be analyzing in various different ways here. So just going to go back to slides, and then we'll start jumping into the actual front end. So the first one we're going to do is Jaeger. So this is when you log into Jaeger, you basically are presented with a search interface. So this allows you to either pick a specific microservice that you want to dig into. In our case, the front end is where all of the transactions start. So I'm going to just hit the front end here. You'll also notice you can add tags, filter down by tags here. So I could look for just errors or just things that have a specific type of metadata. And then you basically hit find, and it builds this graph which kind of shows you the more latent traces over the time period that you're looking at. And so if we jump in, I'll just pick one that looks a little complicated. None of these are crazy. You can see the number of spans listed here. And because it's synthetically generated, it's pretty fixed. So this shows that this transaction took 10 milliseconds. It hit a bunch of different services. And you can basically dig into these. This one doesn't really have any database calls directly, but if I look at one of these spans, this one that took 7 milliseconds, I can actually see all of the tags. This is the structured logging part of tracing. And a bunch of these are added automatically by OpenTelemetry. And then there's all kinds of other metadata that would help you with debugging or understanding where that particular span went. If in your code you're logging, for example, like if you are in Java and you use log4j, OpenTelemetry will intercept that and attach it actually into the trace. So this is basically saying there was some logging that the developer did, and it's showing up here attached to the span that we're looking at in particular. So there's a lot of metadata. If there's a database, you might see the amount of time processed on the back end. You could see the SQL statement potentially, depending on the way it's connected to. There's a lot of other metadata that's really helpful when you're doing any kind of debugging, which is what makes tracing really powerful. We also have, I thought I had system architecture, but I forgot. So the thing is, if you want this part of Jaeger to work, you have to either be using local memory storage, or you have to run Spark jobs, which do all the calculations of the dependency map and view. The nice thing is OpenSearch doesn't need that. I'm going to show you that in OpenSearch Dashboards. That's one thing that OpenSearch does better than Jaeger, is some of the topology views are a bit nicer. We want to improve this on Jaeger, but this was designed for really, really large environments, like at Uber, and they run a lot of Spark to do that kind of batching and calculating. And I don't have the metrics set up, but the monitor tab is designed to give you that metric view inside the tracing system, which comes from Prometheus, but it's another topic for another talk. So now we're going to jump into the same data set. So OpenSearch, thanks to the team, can read the same Jaeger format. The data we were just looking at in Jaeger is actually in an OpenSearch backend in the database. Jaeger officially supports Elasticsearch, OpenSearch, and Cassandra. We have unofficial support for lots of other databases. ClickHouse is popular. But the nice thing with OpenSearch is OpenSearch Dashboards can read the Jaeger format and visualize it inside Trace Analytics. So when we go into the Trace Analytics view, hopefully my session didn't time out, but it could have. You'll see here that there's some aggregation done in OpenSearch. I'm going to just look for the front-end service. Front end, because that's what we were looking at in Jaeger. So the nice thing is, see, it generates the topology view. So you can see in OpenSearch how these are flowing between the different microservices and components. And OpenSearch also calculates the some of the metrics across it. So you can see here on Jaeger, we use Prometheus and those metrics, but on OpenSearch, it actually is calculating the duration, error rate, request rate, all of that data is calculated on the fly, which is nice. It can get slow if you have millions or billions of traces that you're trying to look at. But as we dig into this after the summary view and we want to, say, analyze some of these traces, when I click on this, it should give me example traces, I think. Maybe not. Oh, you have to go down to this tab here. So these are traces. I can obviously filter this and write a query if I were looking for a particular trace ID or some metadata. I'm just going to pull up one of these traces. So this is the trace view in OpenSearch. You'll notice that the timeline view is not as rich as Jaeger. So Jaeger has really nice views of that timeline. In OpenSearch, it's a little more simple. You can see it right here, but it's the same idea. Or you can kind of just look at the list of the spans that are in the trace. And then down below, you kind of have all the metadata associated that you see parsed out in Jaeger, but it's kind of the raw data that's inside that record. So this is kind of the view on OpenSearch. So you'll notice that OpenSearch does some things well that Jaeger doesn't do, and Jaeger does some things well that OpenSearch doesn't do. So the idea is you can store it once and analyze it multiple ways depending on what you're trying to do, which is part of the purpose of this talk, is to say, store it once, analyze it a bunch of different ways depending on what you're trying to solve. And then finally, besides the OpenSearch view and the Jaeger view, the last one I'm going to talk about is Grafana. Obviously, Grafana is really nice for metrics. It's okay for logs. I wouldn't call it great. It's also okay for traces. So in this case, we're going to look at the front-end service, the same one we were looking at, and I'm going to run the query. I already actually ran it when I was checking it earlier. And once again, you can do some filtering by the tags. You can do the same type of search that is available in Jaeger. And you'll notice that there's a Jaeger data source up here that makes it easy to query it through the Jaeger web service. And then I can pull up one of these traces, and Grafana has its own little visualization of the trace. Let me try to find one that maybe has some more spans. This one's kind of using Redis, and you can, similarly kind of dig into these. You'll notice one of the Grafana guys is also a maintainer of Jaeger, and you'll notice that he kind of used the same type of UI where the tags look similar and the visualization kind of looks similar. So this is kind of how the same data is visualized. So we could take this same trace ID and put it into any one of the three tools and get the same exact trace visualized slightly different. I mean, that's kind of the flexibility that you get with these various systems working together. So the idea is that you sort of use best-of-breed tools for different things. That's kind of the way that it's done in open source. It's not unified, but you've got a lot of flexibility, and you only have to store it once. So as I mentioned before, we didn't really talk about metrics. Metrics are super important. Prometheus is very popular for metrics. I wouldn't suggest you put metrics in OpenSearch, even though you can do it. A couple of us in the audience have been through the pain of trying to do that. It is not a good idea. So using specialized systems is a much better idea. Not to mention that the query language that most folks prefer is PromQL, the Prometheus query language, which allows you to do a lot of statistical analysis. It lets you do histograms and other types of queries, which are very hard to do on things like OpenSearch. So it's a little specialized, in terms of what you can do with metrics. The nice thing is that in the stack that I just showed you, Grafana is the preferred way to analyze Prometheus data. It's already part of the stack. It makes it easy for you to go between metrics and traces. I also didn't show you a slow trace or how you would do debugging, but there's lots of, if you look at one of the Jaeger maintainer talks, which I often give at KubeCon, we do that type of demo all the time where we show you how to isolate a problem and see, which issues are occurring. So I didn't show that to you, but that's obviously one of the main use cases for tracing. And I think I ended really early, but that's kind of what I put together in terms of the demo, and I'm happy to take any questions. The one thing I will add is that we just released the first version of Jaeger 2, which is a pretty big re-architecture of Jaeger that bases it on OpenTelemetry. And it has some really nice new capabilities and obviously is very aligned with the project. So you'll find as OpenSearch becomes part of Linux Foundation, better collaboration and integration with other projects will occur. So that means we may see better integration with OpenTelemetry and OpenSearch. The same way that we've done it with Jaeger in the community is how do we build things together instead of building competing or slightly different things, is we want to work together and make this as cohesive as possible. So you'll definitely see a lot more of that now that OpenSearch is part of Linux Foundation. There'll be a lot better collaboration and some great integration with popular technologies. So I hope that we can do more of that between Jaeger and OpenSearch. We've talked about some ideas. But in the meantime, the big thing that we've been doing is a major re-platforming around OpenTelemetry. So you can check out Jaeger 2. We hope to release it at KubeCon in November. It's now in a release candidate state, but we're still working on docs and Helm charts and operators and a bunch of other machinery for Jaeger. So happy to take questions about observability, Jaeger, or OTel. Just raise your hand, and we have a mic assistant. Thank you very much for doing that.
So I'm not quite sure about what's the difference between Jaeger agent and OpenTelemetry agent, and do I need to have both or either of them?
So today, the Jaeger agent is deprecated. You don't use it anymore. You need the Jaeger collector because that writes the storage to OpenSearch. In the new version of Jaeger, the Jaeger collector is essentially an OpenTelemetry collector. Today, the Jaeger collector does accept OpenTelemetry protocol, OTLP, so you can send that from any endpoint or collector to the Jaeger collector, but in the future, you could just run the Jaeger collector, which is OTel, and collect it that way. It just depends on your architecture. I've had a lot of discussions about sampling here at the conference, and you often have to create layers of collectors to do complex sampling. But that's a whole other topic, is trace sampling and how you reduce data and deal with the volumes involved in it. So, but yeah. So it's getting closer, but you still need Jaeger collector. For V1, for V2, not really.
I'm coming.
Can you show a little bit more about where the data is actually stored and then how you're using it as a source in each of those front ends?
Yeah, so the data is stored in an index that Jaeger creates, and then OpenSearch Dashboards reads from that. I think you can see it in, I thought there's a view in, yeah, maybe not. I thought there was a view where you could actually see the indices that it's using, but Jaeger creates the indices. Jaeger can also manage rollover and things like that, or you can turn that off and use ISM or your own scripts or whatever you feel like doing. But there's a standard index that Jaeger creates that has a format, and OpenSearch Dashboards will read the Jaeger schema, or it has its own schema that Data Prepper writes. So you could do either, but the Jaeger schema is kind of the standard. And then Grafana reads the same schema. Does that answer your question, or is it?
Is it on disk in 2 places then?
No, it's on disk in one place on the cluster. In my demo, I have 2 nodes in the cluster, but there's one index. Well, I think it's 3 technically, but those are the ones that Jaeger creates, and the other 2 systems just read from it. In fact, Grafana uses the Jaeger front-end API, the same one the UI uses, and that's how it queries it. So when you set up the Jaeger data source, you just point it to the front-end web service, and it queries it just like Jaeger UI does. So everything in Jaeger is microservices. It all has open APIs, and you can kind of plug and play and do whatever you feel like with it, which is kind of a nice architecture. Yeah, thanks. Any other questions? All right, cool. Thanks for attending. Hopefully it's useful. And yeah, feel free to grab the code and the presentation. Thanks a lot for attending.